These are 3 MCQs from previous year NEET questions. Organic chemistry. First one, hydrocarbon A reacts with bromine by substitution to form an alkyl bromide, which by Wood's reaction is converted to gaseous hydrocarbon containing less than 4 carbon atoms. A is, and we are given 4 options. So it is said A is a hydrocarbon and it reacts with bromine by substitution to form an alkyl bromide, which by Wood's reaction, you know that the product of a Wood's reaction will always contain even number of carbons. Then it is converted to gaseous hydrocarbon containing less than 4 carbon atoms. So that is one other condition which we are given. One is Wood's reaction, then it is converted to a gaseous hydrocarbon containing less than 4 carbon atoms. So if there should be, or it should be having less than 4 carbon atoms, our possibility is that the initial hydrocarbon taken is having 1 carbon atom, because the product of Wood's reaction should have only even number of carbon atoms. So let us see if the initial hydrocarbon, let us take it as methane and see whether it will work or it will fit. So methane is CH4 plus bromine in the presence of sunlight, or bromine in the presence of light, H nu, will give us methyl bromide, that is CH3Br. CH3Br is obtained, and this when subjected to Wood's reaction. So that is, we can write it like this: CH3Br plus 2Na, sodium in the presence of dry ether, plus BrCH3, another molecule. We will be getting CH3CH3 as the product, and 2Na. So here we can see that this is the product which we are getting. This is gaseous, this is having less than 4 carbon atoms. So our initial compound or initial hydrocarbon, and this is an alkane. So our initial hydrocarbon is CH4 or methane. So option D will be the correct choice. Next question is, which one is the correct order of acidity? So here we are given alkynes, alkenes, a substituted alkyne and an alkane. Let us see. Say that these are all hydrocarbons. The acidity of a hydrocarbon is determined by the stability of its conjugate base, that is, base formed by the removal of a proton. So let us take ethine first, the alkyne, CH triple bond CH. When you remove a proton, you get CH triple bond C minus. So this stability of this will depend on the, or it is directly proportional to the hybridization of the carbon atom. So in ethine, or when there is a triple bond, the stability, or it is stabilized by the hybridization, that is, when it is C triple bond C, hybridization is sp. So that means 50% S character to the carbon. So that will stabilize the conjugate base because it is more electronegative, and as a result leaving of a proton or pulling off of a proton is easier. So this will decrease when it is a double bond between the carbons. The S character will decrease to 33.3%. So it will go on decreasing till it is for an alkane. But when you have, say, in this compound CH3, C, triple bond CH. Again here also there is a triple bond, but this group, this methyl group, is electron donating group. So that will destabilize the negative charge on this carbon once the proton or the conjugate base, it will destabilize the conjugate base. So that will decrease the acidity. So acidity is directly proportional to the electronegativity or the sp nature of the hybridization of the carbon concerned. So we can see that an alkyne, that is a triple bond, is alkyne having triple bond, that is it will be more stable or it will be more acidic than a double bonded one. And when there is a CH3 group attached to even a triple bonded carbon, the acidity will decrease. So the correct order will be CH, triple bond CH, this one first and this second, then double bond and then single bond. So option B will be the correct choice. The presence of this CH3 group, that is a plus I effect, that will decrease the acidity of in the case of this propyne. Here, third question, the product formed by the reaction of an aldehyde with a primary amine is. So the reaction of an aldehyde with a primary amine, let us represent the aldehyde as this C double bond O H here, and that on treatment with a primary amine NH2, say R. Removal of a water molecule, and you will be having C double bond N R. So this is a substituted imine. And you call it Schiff's base. So our option C will be the correct choice. So this is a 2016 NEET question. Then NEET 2017 question, which one is the correct order of acidity, and the first one we did was 2018, NEET 2018.